Evolution, as you've probably heard, is a gradual process that occurs over many generations. But what if I told you there was a creature that could change its traits much, much faster within its lifetime? What if I told you this creature wasn't some strange animal you've never heard of, but instead living under our ocean today? Cephalopods, and my favorite example, octopuses.
Wait, but how do they do this?
To understand that, we'll need to understand the process of, drumroll please, A to I RNA editing. A to I RNA editing stands for adenosine to inosine RNA editing. To understand that, we'll need to understand DNA. DNA is a molecule that carries the genetic instructions for the development, functioning, and production of living organisms through coding for what proteins they produce, which leads to their traits. DNA is made up of four main bases, or for us, ingredients: A, T, G, and C. Imagine a super fancy restaurant and you've got a giant cookbook, DNA, that holds every single recipe the restaurant will ever make. This cookbook never leaves the vault and you never write in it because it's too valuable. Instead, whenever you want to cook something, you send an assistant, called mRNA, to make a photocopy of the recipe. That photocopy, the RNA, is what the kitchen staff, ribosomes, actually use to cook. Normally, you follow the copy exactly, but octopuses have a twist. They have a special editor and chef in the kitchen, the enzyme ADAR, or adenosine deaminase acting on RNA. This chef goes through the copied recipe and looks for a very specific ingredient, tomatoes, which we can consider the base A for adenosine. If the chef thinks the dish could work better or differently depending on the circumstances of the day, they swap those tomatoes for carrots, I, inosine. When the kitchen staff, ribosomes, read the recipe, they're trained to read carrots, inosine, as if they were bell peppers, G for guanine, because they look so similar. This in the end leads to a change in the final dish, a protein. Studying this process challenges our traditional understanding of evolution and genetic flexibility. Who knows, maybe one day we'll also have the ability to change our proteins.